Yay! I'm having a real trouble on a couple of these, let me tell you. I must have fallen asleep somewhere in lesson 4 and woke up around lesson 6.
Issues.
I'm sorry, I think you froze. Uh-oh, I lost you. Frozen.
Huh?
You're frozen. Uh-oh. Hmm. Can you hear me? I think I've totally
I can hear you
lost
in and out.
Oh, okay. I thought
Oh.
maybe I totally lost you, but maybe not.
No, I turned off my video, so it should just show my picture.
Okay. All right. Then maybe I can hear you.
Yeah. Yeah. Because now it's coming in a lot clearer for me, at least.
Oh, okay. Good. Good. Yeah, I can hear you better, too. I didn't hear you before.
Okay. Good. How was
Okay. I can't hear you again.
weekend?
Oh. Oh. You're back. Are you back?
Oh, yes.
Okay. I'm starting to hear you again. I don't know about the connection. I think maybe you can move somewhere else in your house that's a better connection or something. I don't know.
Huh? Yeah. It would be loud. That's why I stay in my room.
Oh, okay.
Just as this time it's just kind of bad. There must be a lot of people home though. It's lunch.
Okay. I can only hear about 1 out of every 3 or 4 words that you're saying.
Aw. Well, I don't know. Let's see. Let's see if my phone does any better.
Okay, well, maybe if you give it a second, I can hear the last thing you said pretty well.
Oh, that's good.
Yeah, maybe it's getting better. We're getting a stronger
Yay.
connection. Maybe the longer it.
Yeah. Well, maybe everyone's going to the classes.
Yeah. Maybe they need to get off the internet.
Yep. That's about it.
Get off the internet. It's my turn.
Yep. There she is. Alright. Invite her again. I don't know where
So,
Sari is, so.
did you have a good family evening plan tonight?
We get to go visit one of our counselors who just got called. So, his house is really nice. So we get to go over there.
Oh, well, that's good. That'll be fun.
Yeah. It's fun because I've had him for a class as a professor. So I'm like super excited.
Yep. That's something, if you teach on campus, you're in a bishopric or something of one of the wards.
Yep. Super cool.
Yeah. Cool.
Well, how was your weekend?
Well, it was alright. I taught the Relief Society lesson and
Ooh.
talked with my daughter a lot. She's working through a really difficult struggle right now. So that's
Yeah.
unfortunate.
May she make it through it.
Well, yeah. Well, she's a strong girl.
Yay. Thank goodness for moms.
Yeah, but she's a long ways away.
Is she in the United States or?
Well, she's in Idaho. She's in Boise.
Oh, okay. Yeah.
I'm a long ways away, I should say.
That is true. Very, very far.
Yes. Very far and very cold.
Yeah.
It's like -20 today.
Whoa.
Yeah. And it's going to stay that way. And then it's going to dump another big dumping of snow on us just because I guess
Oh, wow.
it must be fun.
Heavenly Father just thinks you need a little more moisture in your life.
So I kept saying last year we want to send it to California, but it didn't happen.
Oh.
And then here they didn't get anything in January. Like,
Yeah. Yeah, it's been kind of crazy this winter. I mean, here it's been warmer than it usually is.
well, that's good. That's
Yeah.
a pleasant surprise.
It really is, but it's like at the same time you worry for the farmers that are all around here that have to deal with the decrease in water.
Yeah, that's not good.
Mhm.
So, where is Sari, I wonder?
Send her a third invite.
Pardon?
No, I was going to send her a third invite.
Okay, maybe. It took 3 one time for me to hear it or to get
Yeah.
it, something.
Gotta hope and pray. Maybe she's out with the puppy again.
Maybe. Those little puppies, they need a lot of attention.
Mhm.
Well, I printed off the whole thing today. I mean, of the test review.
Mhm. Yeah, I haven't gotten to look at it. I blame the Super Bowl.
Oh, well, it looks like New England won that, didn't they?
They did. It was a good game.
I guess.
It went well.
I didn't watch it.
Yeah.
My
I
husband
hadn't planned to watch it. Yeah.
My husband's anti-football.
Ah.
like football, so there's no temptation here to watch it.
Ah, lucky. Yeah.
But it looked like it
SAT
was
brothers
up
were
and
like, it was like they'd score and then the other team would score and it just went up the whole
There
time.
she is.
It was good.
Yeah, there she is.
Woo!
Yay, Sari. We need some help.
Oh, yeah. Have you guys started that whole review paper?
Yes.
Okay. I did okay on some, but like the last 24 through 32, I like can kind of figure it out, but then I'm like, I just.
Oh, yeah. That was where I drew a blank. I
Yeah.
said, I was telling Kelsey I must have fallen asleep somewhere in lesson 4 and woke up about lesson 6.
Yeah.
Yep.
Well, like I remember bits and pieces like where like number 27 where it says like find the 10th percentile. I'm thinking you have to go in the applet and do something, but like put in the 10th percentile and then I don't know. I just like I know steps of it, but then I'm having problems putting it all together. So
Yeah, and getting
Yeah.
question, kind of off topic. Did you
Yeah.
guys get the email I sent you about what the professor responded with?
no,
our questions?
I haven't checked it yet. No,
Okay.
Yeah, I did. It's
Yeah.
Okay. What did she say? I can read it later. It's not big.
Yeah.
she sent us a copy too in our email.
Oh, okay.
Okay, I didn't know if you guys got it.
Oh, okay.
So.
All right. Well, I have to be somewhere in like an hour. But let's try to do as much. Can you guys meet like tomorrow possibly? Because I know we have to take the test before Thursday. Is that?
Before when? A Wednesday night, I think.
saw Wednesday. Yeah. I saw Wednesday
Could
on
y'all
iLearn.
tomorrow morning early like we have before? Or
Let's see.
I'm okay with that. That works always for me so much better.
oh, I mean, we can go. I can stay here till like 3:05, but I have to run and get my daughter.
Mhm.
from school. So we can do
Okay.
as much as we
Well,
can.
let's see what we can get through, because
Okay.
yeah, there's some things I haven't
right.
figured out either. Maybe none of us know how to do it, and we'll have to meet back and see. So number 1,
Yeah.
what is the name of the important statistical result that guarantees that the sampling distribution of the sample mean will be normal if the sample size is large?
I put
To me, yeah, that's a central limit theorem, right?
Mhm.
And then the second one is, what is the name of the important statistical result that states that when the sample size is large, the sample mean will be close to the population mean? That's the law of large numbers.
numbers. Yeah.
So I think we finally got that straight, where we missed them on our quizzes.
Yeah.
We got it straight.
Right.
And which of the following variable is categorical? That's the number 2, a randomly selected brand of toothpaste at a convenience store.
Right.
Okay? Right. So those were easy so far.
Mhm.
Okay. Okay. 4, the mean IQ test score in the United States is 100. 20 randomly selected statistical students took the IQ test, and the mean of their score was 112. Which of these two numbers is a parameter, and which is a statistic?
I put the 100 as the parameter and 112 as the statistic.
Yeah.
Okay. The mean parameter. The mean of the scores. Okay, I was a little confused about that one. I wasn't sure.
It says in the notes, like I looked back in my notes. Let me see. I think it's
It wasn't the 20 randomly selected students.
what? Are you on number 4?
4, yeah.
Yeah.
20, yeah.
No, all you're gonna do is say the answer is. It's just asking for which. It's just saying like which one's the parameter and which one's the statistic. The 100 is okay. So the U100, the parameter is like the population mean, and the 112, the statistic is like the sample mean.
The
That's
X.
It's just
Example.
asking to answer it like that.
Okay.
Yeah.
Okay.
So
I did think the statistic was 112, but I didn't really know why I thought that. But
yeah,
anyway.
just doing like I read it somewhere too. I
Okay.
can find it in my notes, but
All right. We'll get to the harder one. So we won't read number 5, 6, and 7. What did you? I got stratified sample for 5.
that's what I did. That's my very first answer. But then like I haven't. Is there like an answer sheet or is there not?
No.
Yeah. Okay. I put because I wasn't sure like if we were supposed to use all 4, like 5, 6, 7, 8. So then I did like the elimination, like because I didn't know like if we could repeat some of these on them or each one of them was supposed to be one of those different.
Yeah. I don't know.
Yeah. So I put stratified, then I crossed it out and put systematic because the next one I put cluster, then the next one I put simple random, and the last one I put stratified.
You put random. I put convenience on number 7.
Is there a convenience one? I didn't even know that was one.
The name of each person who attended was entered. I don't know. When when they sample all the people that have a doctor's appointment, then that's a convenience. They just sample everybody that goes in.
Okay.
So I don't know. That could be wrong though. I'm not sure.
What did you put, Kelsey? Did you?
I'm still trying to comprehend it.
She's still working on that.
Okay.
Yeah.
For number 6, did you put cluster, Lynn?
I did, yeah.
Okay. Okay. So, and then the last one, what did you have? Stratified?
Stratified.
Okay.
So for 5, you put what? You didn't put. You went back and crossed it out and put what?
My first answer was stratified because that made sense to me. But then I could kind of look at it in another way and put systematic, like. But I don't.
Well, they didn't randomly select one to start out with. You know, they didn't say the 5th person of this. So, and it didn't say that. So I don't.
Okay, I think it's stratified. That's
okay.
I'm gonna go with that. And then I think you're right on the convenience. I actually didn't see that. I didn't even think, but I guess yeah. Okay. Let's go, I guess, for number 9, the mean.
Okay.
This was, y'all used your little, like, SBS, the SBS on these.
Yeah, and it was the
4
I had to look up, I tried several different things, and then it was the analyze, descriptive statistics, and then explore.
Uh-huh.
And then it was the
mean was 4.7.
The box to get the box.
Oh, the 5-number summary.
Yeah.
Yeah. Well, did you go to the percentages thing like we did that one time, where then it put all the like the 25% and then like.
Right, because you had to click the box that said percentage.
Yeah.
You went into, you clicked statistics, then clicked the box that said percentage. I had to go back and look at that because, anyway.
It took a while too. So I have for the minimum 0.84.
Right.
And then the first quartile was 3.39.
Yeah.
And then the second was 5.15. And
the median, yeah.
Yeah, and the medium, would have been the 4.771. Is that
the median? I got 5.1.
Oh, I mean 5.15, right?
Right.
Okay, and then the
3.
Yeah, is 5.7.
Yeah, and the maximum 10.45.
Yeah.
Okay.
Yeah, that's
and
what
then I did create a histogram, but I didn't save it.
Yeah, that's what I did too.
Okay.
Okay.
And then, so.
11A, I got 0.42.
Point what?
0.42?
No.
No? Okay.
I looked about how we did that. I have a couple different ones in my notebook that I wrote down. It was the observations of the severe case of whatever. I think it was temperatures they were talking about.
But isn't it like 37? Because when I was looking at how we did that, isn't it like, so it's x minus the x with the thing over it? That's what we're trying to solve for is a. So isn't it 37.91 subtract the mean, and you add up all those and divide by?
Well, you have to find the mean.
Yeah, you have to find the mean.
Okay, so what did you get for the mean?
I wrote that down. 38.33.
30. I got 38.075.
Oh. Huh. Let me try this again.
Okay.
7.91. 30.91 plus 37.25 plus
0.075?
8.98 plus 38.16 divided by 4. Oh yeah, you're right. Okay, that's probably why I'm off. So it's 38.075. Is that what you got?
Right. That's what I got for the mean.
All right, and then you subtracted. Yeah.
And I subtracted each one to get the standard deviation, right?
Right.
And then you squared that.
Right.
To get the last column.
Right.
Right. And then when you add up all those squared deviations, then I got 1.53995 or 1.54, I guess, if you wanted to round it.
But what did it?
So that was, let's see. So that point, just a second. So then to find the variance, you take the sum of the squared deviations from the mean, which was the 1.53995 or 1.54. And you divide it by n minus 1, the number of samples. So 4 minus 1, which is 3. So for the variance, I got was 0.5133.
Okay, so were we supposed to do all that? Or which problem are you?
Oh, maybe we weren't.
Oh.
Maybe we weren't, but anyway, I was just figuring that because
what you're doing.
we had to figure out the standard deviation of the temperatures.
Yeah.
And so, but in order to do that, I had to figure out everything else.
Everything else. But what did you get for number 13? Because I was confused on that. What quantity?
13. Well, okay, so the quantity is equal to the sum of the numbers in what quantity? Squared deviation column. So I added up those squared deviation columns. I got 1.5, but that wasn't the variance yet because you have to divide it by the number of the sample minus 1 to get the variance.
Right.
So I put none of them.
That's what I put too.
Yeah. Because you didn't divide it yet.
Yeah. So that's what I put. Well, I didn't know. I couldn't figure it out, so I put I didn't know when I mean.
But 14. That's, I guess I was getting to that when I was. You get the variance, and then you do the square root of the variance, and then I got 0.7164.
Mm-hmm.
But you wouldn't have got that because you had a different number.
I actually got 0.715, so I was.
You got what?
0.715, so somehow.
Oh, okay. So that was really close.
Yeah, but my numbers were off a little. So, number 13, what quantity is equal to the sum? Is that just that was just like a trick question, right? Like there isn't any.
Well, yeah, that's they were calling. They just said that was the sum of the squared numbers. Yeah, it's not quite the variance because you had to do one more step to get the variance.
Right.
dividing it by n minus 1.
Okay. All right. And number 15, under certain conditions, the standard deviation can be negative, not false. Right?
I put false too, because probability can't be negative. I've thought about that one for a long time. I left it blank for a while. I came back and
yeah, I was trying to think too, but then I just remember it. Yeah, it couldn't be somewhere.
Probability.
Yeah.
So
16.
okay, 16. Okay.
I put that you couldn't solve that for some reason. I couldn't.
Oh, okay. I did get this one. Let's see, 16.
Which location role in the most consistent temperature measurements from this one seal to another justify your answer? I didn't think that there was enough information given in that thing to show how are we supposed to, we don't have the standard deviation. Or,
yeah, we do.
Well, oh yeah, we do. I mean, we don't have
Let's see.
other information, like the whole plot, to know, like, I don't know.
Which location resulted from the most consistent temperature measurements from one cell to another? Okay. Well, is that the question you're talking about?
Mm-hmm.
Okay, I put the extradural because the standard deviation was smallest. It's 0.577. And when the standard deviation is smaller, it's closer to the middle. I mean, it's closer to the mean.
Okay. It's closer.
Like on our applet, the mean is in the middle. And if it's a smaller standard deviation, then the lines are really close to that, right?
Yeah, it just says, like, which
And so-
location resulted in the most consistent temperature measurement. So, to me, that was like asking.
Well, then it would have the smallest deviation
Yeah.
if it was consistent, right? Am I thinking right on that? Because if there was a huge deviation, that means the
Yeah.
numbers are just,
Yeah, I think
they're farther apart.
small deviation is more consistent. Yeah.
Yeah.
Let me just make a note on that. It seems like I remember learning that, and I actually, that was, when I was looking at that, that was my first guess. Like, it's the smallest one. But then I was like, no, I think I sometimes I overthink.
Yeah. Well, I'm hoping you're going to help me with these other ones that we're coming up on. Because, I don't know, I just drew a blank on some of these.
Yes, okay. 17 is a measure of the spread in a distribution. Wait. Oh, the answer. This is the answer for number 17. The definition of a standard deviation is a measure of the spread in a distribution. If the standard deviation is small, then the data tend to be close together. If the standard deviation.
You just answered that. You just answered the question above.
Yep.
If the deviation is small, so I put how far away from the mean the number is. But you made it a fancier answer.
Yeah, and then if the standard deviation is large, the data is more spread out. Okay.
Right.
So
Okay, that's right.
18, let's see, I did.
That was that box plot.
Yeah, so I put the minimum.
4, 6, 8, 12. Yeah.
Yeah, so the minimum is 2, the first quartile's 4, second
Right.
or median is 6, and the third is 8, and the maximum is 12. Is that what you
Right. Yeah. And then the percentile that lies between the 4 and 8 hours.
I put 50, but
50%. That's right. Because we missed it on our test that one time.
right.
So if we miss it, then I remember it for sure.
Yeah. And then 20.
Now.
20 down. I'm little start.
This is where I drew a blank. This is why I said I fell asleep somewhere in chapter 4.
I tried on 20. What I started thinking in the direction you may have too is to draw the box plot thing out, like it says.
I didn't draw the box plot. I was drawing the bell curve with the deviations to it.
Oh.
And I still can't get it. Okay, so I think it's just these are just confusing. It doesn't give me enough
It doesn't give you enough.
enough information.
That's what
So
yeah.
if 1.59 is a -2 on the standard deviation, okay, because it's talking about in the question,
Mm-hmm.
it's unusual if it's more than 2 standard deviations away.
Mm-hmm.
So if it's beyond that 95% of the data, 2 standard deviations away.
And it's unusual.
Okay, then it would be maybe above that 10 parts per million. Okay, but okay, so the 2 negative standard deviation away was 1.59, and the 2 positive deviation away is 2.